Hello everyone, welcome to today's class. We are continuing our class on geometry. Last class we stopped at theorem 3 and we are continuing with theorem 4. Theorem 4 states that the sum of the exterior angle of any convex polygon is 4 right angles. What does it mean? It means that when you have, let me say you have something like triangle like this, the exterior angle is when you keep on extending the side. The angle you form when you extend the side. They're trying to say that the sum of this angle is what? 4 right angles. And I remember I told you that right angle simply means 90 degrees. So it means 4 times 90 degrees. That's 360 degrees. So if this is a square, you extend here, extend here, extend here, extend here. The angle you form here, 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 and here. I'm trying to say that it is always 90 degrees, irrespective of the number of sides, provided that it is a what? Convex polygon. So this is a polygon I drew. This is the main polygon. This is it. This is the polygon. As you can see, this has many sides. So this I extended this to form the external angles. I extended the sides just to form the external, or like an exterior angle. So they're trying to prove that the total number of all these exterior angles will be 4 right angles. So the way we are going to prove this one is to do a dot here and start drawing parallel line. What are parallel lines? Parallel lines are lines that can never meet each other. They are moving in the same direction. They can never meet each other and they maintain the length that they are moving. If two lines are moving like this and they can never meet, and this line, the distance of their line, no matter how far you draw it, can never increase or reduce. That's a parallel. I think this is a layman explanation of it. So let's call here A, call here B, call here C, call here D, call here E. I will not label the rest. They simply symbolizes the number of lines can be as much as possible. So let me just call here N. N means till the number of N. It's like saying, like writing a notation of, writing this kind of notation, A plus B, let me just use plus C plus D plus E dot N. That's what we just did here. I know we can count this, but we're just trying to say that we are dealing with as many numbers as possible. So N is wherever we are going to stop. So this is the number, the sides. So this A form angle X, this B form angle Y, C form angle Z, and so on. So first I would have here an origin O. I will not try to do a parallel line where I will have my, this is my A, right? I will not do something like this. This is my N. I'll try to draw a parallel line. So a line that is parallel to this line. So if I'm to draw it sketch, it will go like this. Let me call here O, call here P. I'll do another one. After this is the next line. Do another parallel line, trying to capture this. Okay, it should be like almost straight. I'll call here Q. This is the next one. I'll do another thing like this, trying to make it parallel, so it will follow the same direction. I'll call here R. This is the next one. It bends. It's like as if it's straight, but it bends more. I don't know if I'm getting it. This is a sketch just to explain it. I'll call here S. In the same way, I'll do for this. It's going like this slightly. As you can see, it's now joining with this one. I'll do for that. I'll do for that. Where did I stop? I did here. Then I'll do for this. So this is where we started. So this is what we've got. So if you look at this diagram that I drew, this is parallel to this is parallel to that, and so on. You notice that at the end of the day, the lines now converged at a point. I don't know if I'm making sense. They finally converge at a point. And here that we have this and that. At the same time, we also have this parallel to that. So it simply means that this angle here, let me call it A, will be equal to what? X. So I can say A is equal to X. At the same time, here is parallel to this, and here is also parallel to that. So whatever angle it forms here, let me call this B, will be the same as this. Since this line and this line is parallel, this one and that one is parallel, wherever they converge, they will always form the same angle because they are parallel lines. You understand? So at the same way, this one is parallel to this one, and this one is parallel to this one. Wherever they converge, they will also form the same angle. This is C, and so on and so on. So I can say A is equal to X. At the same way, Y is equal to B. At the same way, C is equal to, what am I saying? Z. I think I'm messing it up, but it's still the same shit. Z is equal to C. Normally, A, B, C is supposed to be one side, X, Y, Z is supposed to be one side, but I think I messed it up, but it's still the same thing. So by the time you continue checking, you notice that here will be equal to here, here will be equal to here, here will be equal to here, here will be equal to here. So what we finally establish is that all the angles we formed here is equal to all the angles we formed here, because they are parallel line. So wherever a parallel line meets, they always form the same angle, so long as they are parallel line. Like, what I'm trying to say is that two parallel lines never meet. Like this one, this is a parallel line. They can never meet. But what I mean by meet means this is parallel to this, and now this is another parallel line. These two. So wherever these two meet, we give you the same angle that these two are giving you. That's what I mean. So by so doing, we're able to prove that this angle is around a point, and from our geometry, any angle around a point is what? 4 right angle or 360 degrees. So for that reason, it means that these exterior angles are all equal to what? 360 degrees, which is the 4 right angles that we are talking about. So I don't know how I can just say this. Total angle here is 360 degrees, because it's angle of a point, and we all know that all these angles are equal to all these angles. So both of them shows that our theorem has been proven. Total exterior angles equal to 360 degrees, which is the same as 4 right angle. Let me just do a little example. Let's say I draw an equilateral triangle. Just a little example to prove that this theory is work. Equilateral triangle has all the angles equal, right? This is 60 degrees, 60 degrees, 60 degrees, right? So let's do an exterior angle. 1, it will be 3 now because it's 3 sides. 2 and 3. So now we are trying to confirm that the sum of this and that will give us what? 4 right angle, which is 360 degrees. There are different ways you can do. You can say that this is on a straight line. So total angle of a straight line is what? 180. So 180 minus 60 here will be 120 degrees. The same applies here, 120 degrees. The same applies here, 120 degrees. So by the time you say 120 degrees plus 120 degrees plus 120 degrees, you are getting what? 360 degrees, which is the same as your 4 right angle. You can now say, oh, because it's a triangle, let us try for square. Should I go to the next page? Okay, let me go to the next page. Let's try for square. This is a square. Mind you, I'm doing a rough sketch. The total angle of a square is what? 90 degrees. So let me illustrate it. It is right angle. Right? So let me do an exterior angle. If I do for this like this, exterior angle, and what? Exterior angle. So remember that the total angle on a straight line is what? 180. So here is 90, here will be 90, here is 90, here will be 90, here is 90, here will be 90, here is 90, here will be 90. So by the time you add the 4 90s plus 90 plus 90 plus 90, so you're still getting 360 degrees. So you can try as many polygons as possible. You see that you are still coming back to this 360 degrees. In that case, we'll be able to prove this one. Let's go to the first example of this chapter. So we are solving our first example for this chapter. Example said ABCDE is a regular pentagon. Take note of this word regular. I will explain it. The sides AB is the side AB, and DC. Where is D? Where is C? I think I'm missing C. There's supposed to be C here. And DC are produced to meet at X. So it means this AB and DC extended till they meet at X. That's what I mean by produced to meet at X. Show that triangle BDX has two equal angles. They're trying to tell us to show that this triangle here, that it has either this angle and this angle is equal, or this angle and this angle is equal, or this angle, I don't know. Just shall know that inside these three angles that it has, two of them are equal. Now, when you are dealing with geometry, first thing you need to know is that there is no formula. Just for you to be remember your theorems and then apply your wisdom. But one thing I want you to know is that whenever you see this line, as you can see, it simply means that wherever you see that line has equal sides. And you know what happens to a polygon, or whenever a polygon has equal sides, it affects the angle too. That's why you hear something like ABCD, ABCDE, okay, E are regular. Regular means whenever you hear of regular, it means the sides are equal. You understand? This is a pentagon because it has 5 sides. It could have another shape where A is bigger than B, but if we hear regular, just mean they are talking about equal sides. And whenever there is equal sides, obviously there is also equal angles. So these are the things you need to note. So this line, take note of it. Another question you ask me is, what about if this line are equal and this line are equal? What do they do? It's simple. They will use one line for one, but let me say they want to show that this and this is equal. They will use double line. So wherever you see double line around it, shall know that those ones with double lines are also equal. These are the simple tricks that you need to know. Another thing you need to know is about this, how to read these alphabets. See how I read this A, B, C, D, E. A, B, C, D, E. Now I know I'm talking about this pentagon. Look at the triangle. They say we should prove that it has two angles, BDX, BDX. So know how to read those things and picture what they are talking to you about, so you don't miss it. So first thing, they told us to prove that this triangle BDX has two of the angles equal. So first place we are going to start with, let's assume we start from here. Since this is a regular polygon, this Z is an external angle of this regular polygon, the same as this Y. But because it's regular, it means that all the external angles will be equal. Remember what we did when we were proving this 90? Because this is a square. Square is like another regular polygon. You see all of them are 90, 90, 90. Even when I did for the triangle that is equilateral triangle, see that because all the sides are equal and angles are equal, see that the external angles exterior angles were also equal. So for that reason, if we come here, we can comfortably say that Y is equal to Z, because both of them are exterior angle of a regular polygon, so they will have equal answer. And what did I say is the formula for exterior angle of a polygon? Sorry, what did I say is the total angle of exterior angle of a polygon? We say it's 4 right angle from our theorem 4. So for that reason, since this is 5 sides, and we all know that it's a regular polygon, so all the exterior angles will be equal. So it means that whatever you get here is what you will get here. Is what if you extend this one, that's all you still get. If you extend this one, that's all you still get. So to know what Y actually is, it means that this will have 5 exterior angles, and because 5 of them are equal, to get the answer for one, you simply do 360 divided by 5. So this will be equal to 360 divided by 5, just to get the answer to one angle. The answer is what? 72 degrees. So y is 72. Y z2 is also what? 72. So let us use that and find the angle, this angle x. Since this is a triangle, we know from our first theorem that total angle of a triangle is 180. So here is 72. I can write it at 72, and here is 72. So to find here, I will say x, I will say 180 is equal to 72 for y plus 72 for z plus x. So x will now be 180 minus 72 minus 72. That's when this cross the equation. So x will be what? 36 degrees. So I can write it here, 36 degrees. So the next thing we want to, because our main focus is this triangle, remember, BDX, BDX. That's why I say I solve for this so I can get this. So let me try and get these other sides so that I can be able to know if any of the two angles are equal. Mind you, this is the angle we'll be looking for, and this is the angle, not one of this side, because we're talking about BDX. So the next thing we are going to do is that I know that this thing means that these two sides are equal, and if these two sides are equal, it means that these two angles also are equal. Are we making sense? Because the sides, these two sides are equal. Because these two sides are equal, these two angles too will be what? Equal. Okay, it's like an isosceles triangle where two sides and two angles are what? Equal. So now we already know that from our theorem 2, if I'm not wrong, that theorem 2 or theorem 3, that the sum of external angle is equal to the opposite interior angle. Sorry, the external angle is equal to the sum of the opposite what? Interior angle. So it means that this A and C will sum up to give you 72. I already know that from this line here that A and C are equal. So it simply means that A and C are equal, and they are 72. They are equal to 72. So in that case, A plus C is what? 72. But since A and C are equal, you can likewise call it A plus A. You can say A plus A is what? 72. So 2A is 72. So A is what? 72 divided by 2, which is what? 36 degrees. So here is 36 degrees. So to get the angle here, it will be 36. Sorry, I was also write 36 degrees, I wrote 360. So this is 36 degrees. So here plus here will give you 180. So here will now be, although there is not necessary since we've already been able to establish that two angles are equal, but let's still find the last one. So it will be 36 plus 36 plus this angle, let me call it angle B, is 180. So B is 180 minus 36 minus 36, which is equal to what? So this place is 108 degrees. So what matters is that we were able to establish that from the question, show that BDX has two equal angles. So these 36 and 36 are equal. So we established that. Let's solve the next example, which is example 2. So let's look into example 2. In figure 2.7, this is my figure 2.7. This is my figure that I drew here. Side BC, as I said, always take note of this lettering and relate it properly. Side BC, this is BC of triangle ABC. ABC is produced to D. Produce means it extends to D. The bisector of ACD, this is ACD. The bisector, whenever you hear bisector, means it bisects it equally. So let me say, call here Z and call here Z. You understand? whenever you hear bisect, know that there is an angle here that this thing bisect, so it's equal whatever that is here is what is the same thing that is here. So what I say, the bisector of ACD meets BA, that it meets this BA, produce the to X. So this BA produced to X, so this one meets it there. Prove that X, that's this angle, let me call it X here also, angle X small x is equal to 1 over 2, that's half of BAC minus B. So I'm trying to say we should prove that this is equal to, let me call here A, call here B, call here Y. So I'm trying to tell us to prove that this X is equal to this minus this, whatever you get, half of it. Are we making sense? So in this case, there is no line to start considering which side is equal, which side is not equal. So we are dealing strictly with angles. So as we already know, since this bisect this equally, this is Z and also this is also Z, right? That's sorted out. Now let's look at, we are looking for X, trying to prove that X is equal to this minus this, half of it. So I already know that X, Y, Z, since we are dealing with, this is an angle, since we are dealing with triangle, is equal to 180. So I'll say X plus Y plus Z is what? 180 degrees, because it's a triangle. At the same time, I'll now make X subject of the formula. It will now be, X will now be 180 degrees minus Y minus Z. At the same time, we all know that any angle on a straight line is 180 degrees. So this A plus Y is what? 180 degrees, right? So when we make Y the subject of the formula, Y will now be 180 degrees minus A. Are we together? Now, remember what we said, that the exterior angle is equal to the sum of the two opposite interior angle. Now, the exterior angle here is what? 2Z. I don't know if I'm making sense. So the exterior angle here is 2Z, because Z plus Z, that's what makes up this exterior angle, as I labeled it. So I'll say 2Z is what? A plus B. A plus B. What I'm trying to do here is, we have been told to prove that this is equal to half of this, half of A minus B. So I'm trying to bring this X as how will I go, as a formula into an equation with A and B. So first we did the summation and we just make X the subject of the formula. So now we have Y and Z, but what we actually need is A and B. So I will now look for a way to express this Y in form of A and B. That's why I now said Y plus A, we all know is in a straight line, is 180. So I made Y the subject of formula. Now I see it's already in the form of A, which I will replace here later. Now Z is something I need to replace. So that's why I now have 2Z is A plus B. Therefore, Z is 1 over 2 A plus B, as you can see. Now I've taken care of my Y and my Z, so I'll now put it inside this my equation. Let me call this equation 1, so that I will now have a relationship between X, A and B. So X now be equal to 180 degrees minus Y. Y is now 180, so I'll put it in bracket, minus A, or minus again Z. Z is now 1 over 2 A plus B. So when I open up the bracket, I'll have my X is equal to 180 minus 180. When minus times plus, it becomes plus. When minus times minus becomes plus, plus A minus 1 over 2A minus 1 over 2 B. So this 180 will take out each other. Then here we have A minus 1 over 2A will give me what? 1 over 2A without minus. Why this minus B still remains? So X will now be 1 over 2A minus 1 over 2B. When you take the 1 over 2 out, it will be equal to 1 over 2A minus B, which is what they told us to prove that X, just that now we are using the smaller alphabet. So if you want to write in the big alphabet, this small x will now be replaced with this big X. Let me say this, let me take it up here and say this equal to X. The big X will now have cap is equal to 1 over 2. This smaller a will take up to what they told us, B X C. You can also replace it, since there is a line here, you have to take note of the 3. But if it's staying on itself, I think I made that mistake in the last class. If it's staying on itself alone, you can, like here that X is staying alone, you can use only the X. But here now it's not alone, so you have to consider, take 3 lines so that people will know which of the angle you're talking about, that you're talking about this angle in particular. So here will be B A cap C minus what am I doing? Sorry. Small b will now be capital B with cap on top. So this is what we are told to prove, and we're able to prove it. This is our answer. 1 over 2 small a minus small b. And this is small x that is giving us this. So now, but because it's written in the capital form, that's how I translated it. This small x becomes big S with cap. 1 over 2 is 1 over 2. In the bracket, that small a will now be B A cap C. This is what is in the bracket. While small b will now be capital B with cap. So in the next class, we're going to solve our exercises. If you have any question, you can drop. See you in the next class. Thank you.